I hope everyone enjoyed lunch. So I'm here to talk a little bit about multi-domain operations being enabled by 5G. 5G is the buzzword in technology right now, and I really want to cut through a lot of the hype around 5G and really talk just about what it's going to enable for the United States Air Force and what we're doing to enable 5G nationwide, as well as for the enablement of multi-domain operations. And so what I want to start with is just where we've been and what is our path to 5G. What are we doing to get to 5G deployment so that it's becoming more real than just the hype and potential and promise of the future? And that really underlays a lot of what Mr. Marion just talked about in terms of the journey, the evolution, the transformation that the Air Force is going through right now. We have precedent to learn from in enterprise. Enterprise, the largest telecommunications companies in the world, have been enabling and transforming their networks through network transformation to get to a point where we have our own version of multi-domain operations. And so we can leverage what we've learned over the last really 10 years as we've been on this journey on a lot of the items that Mr. Marion talked about. What have we learned? What have we done? And then what can we bring to the United States Air Force to enable the innovation that we see here today? Walking the floor all day today has been truly enlightening. A lot of these technologies, a lot of these solutions will work better on the networks of the future, but we have to enable those networks first. And so that's what I want to talk about today. The drivers of this change are not unknown to any of us. We know that there's more devices being connected to networks across the world today than ever before. That number will reach 20 billion next year. We know that there's more clouds and more areas where our data is being stored. This can be on the edge, this can be in a cloud environment, this can be on-prem in a data center. But more than 85% of companies have data in more than 2 clouds. We also know that there's more data being generated than ever before. And a lot of this is related to social platforms and how consumers and how citizens use social platforms. But there's data out there to be mined. There's data out there to be leveraged. There's data out there that we can learn from. And then lastly, there's more people in more places. The Air Force has been expeditionary for decades, since its inception. But now enterprises over the last 10 years have been dealing with this as well. How do you support getting the right data to the right user wherever they may be, even if they're not in the 4 walls of your office, even if they're not on your traditional corporate network? How do you get data to these mobile users? And this is something that enterprises have been facing for the last 10 years. And this is something that the Air Force has also struggled with. So if we align these 2 areas of opportunities, these 2 areas of interest within enterprise and what they're dealing with and within the Air Force, what can we learn from transitions before we get into the promise of the future? Verizon's been on its own journey for the last 10 years. A little over 10 years ago, we started making the recognition, the realization that the network is just too big to be able to manage in the old traditional ways. Right, so Verizon is one of the largest global network companies in the entire world. With the amount of data that we're pushing through the network, can't be managed in traditional ways. And so we were forced to look at software-defined networking that Mr. Marion was talking about, mesh networking, networks of networks. So networking at the base level at fiber, whether it's undersea, on land, or satellites in the air, or terrestrial-based wireless systems. We have to make sure that we can enable network of networks. And not only that, the journey to SDN, to software-defined networking, was important to us because we have a tremendous amount of security requirements and compliance risk within Verizon because we have thousands of customer networks, agency networks, federal networks, enterprise networks that rely on the Verizon network at its core to be able to build on top of that. We also have hundreds of interconnections between carriers around the world. And so us and our telecommunication peers know how to do interoperability, interfacing with networks across the world to be able to deliver data at the point of need. But in order to do that securely, you can't just rely on traditional firewalls and traditional security equipment, and that's why network virtualization has been so important. And so a lot of the hype, a lot of the buzzwords that you hear in IT conversations, in technology conversations around SDN, NFV, all of these newer, over the last few years anyway, networking terms, it's for a reason. It's It's because the largest companies in the world that have to manage the largest networks in the world realized this 5-6 years ago that this is important. And now the largest enterprises and agencies are realizing it's important for their own operations. So how can we learn from what Verizon has been through over the last 5 years when we started implementing SDN on our network, and now we're at almost a fully virtualized network globally with 79 terabits per second of data being transmitted over our network with 6 nines reliability? How do we bring that expertise to the United States Air Force and leverage your applications on that reliable, resilient network? And so that's one of the items we're talking about. The other item that we're talking about is how do we do that for others? How have we leveraged this network, this investment, this innovation for other agencies, other enterprises? And so I thought this was relevant. This is one of the largest airlines in the world, work with Verizon, to identify how do they improve passenger experience. Don't take that as, all right, what airline did you fly in on and how well was your passenger experience? I had a great flight in last night. The opportunity here to recognize is that this is a mission for them. This is enabling a mission outcome. And if you start with it from that perspective of how do you enable a mission outcome that is delivering a highest level of passenger experience that you can possibly deliver, and then how does that work its way all the way back into technology, all the way back into multi-domain operations, all the way back into IT and networking. If we start with that at its core, as its North Star, as the idea of why we're doing this, that airline was able to connect people around the world, a mobile workforce. They were able to connect through SDN, software-defined networking, interconnections between other airlines across the world, as well as municipalities, port authorities, all of the airline operations. And being able to do that and transform their operations started with the network. It went to IT, it went to data management, cybersecurity, and then it led to improved passenger experiences. So they started with the end in mind and worked its way to the beginning. So this is the background. This is the proverbial setup. We've been on this journey for 10 years, and a lot of the conversations we're having in the United States Air Force right now is about continuing that journey. They're just at a different point. We want to help enable that transition, that technology innovation, that network transformation to get from traditional networking to software-defined networking to network function virtualization in support of the mission so that you can enable true multi-domain operations. What's next? Where are we going? Where would we be saying that we'd be going? If it was 10 years ago today, we'd be talking about the evolution of SDN and NFV. The next 10 years are going to be all about 5G. Verizon and some of our closest competitors are betting the future of our $200 billion plus organizations on the next generation of networking to be able to enable the solutions you're talking about, to be able to deliver true multi-domain operations, and that's 5G. But you don't get to 5G by accident. So these are the 4 building blocks of 5G, and I know there's a lot of conversations around, do we use commercial 5G? Do we rely on the telecom providers to use 5G? I'm not here to sell you on Verizon and Verizon 5G. I'm here to sell you on the benefits of 5G and what you need to do to get there, and what we've been doing over the last 10 years to get here. And these are the 4 elements. You need tremendous amount of fiber. Your fiber, someone else's fiber. Mr. Marion made a great point on network of networks, and some of your data is going to go over untrusted networks. And if you operate in a global environment on 5G, you're going to be using multiple fiber connections. But you need fiber. You need fiber to the point of need, fiber to the small cell, to be able to transmit the amount of data that you're talking about. The second is you need spectrum. Spectrum is the lifeblood of any wireless network. Verizon invested in over 1,000 megahertz of contiguous spectrum in the millimeter wave. We believe very strongly that millimeter wave is going to deliver the true promise of 5G. There's a lot of different competing thoughts on that. You can deploy 5G on many different spectrum types, spectrum waveforms, but you absolutely need a tremendous amount of spectrum. When we deployed 4G 12 years ago, we invested in 20 megahertz of spectrum, and now we have 1,000 megahertz of spectrum. That's the amount of spectrum that you're looking at leveraging for 5G. The next is software-defined networking. I've touched on that. That's that journey, the evolution that is going to be enabling all of these networks, and I'll talk about that in the next slide. The last one is multi-access edge compute, and I know I've been traveling, I've been walking on the floor, and I've been traveling the country to talk a lot about multi-access edge compute with a lot of innovators like yourselves. This is the true promise of 5G. And a lot of what we're doing in 5G with multi-access edge compute with MEC is built on what the Department of Defense has been doing in tactical environments for some time. It's the idea of no longer of, do I store my data in my own data center or in the cloud, and which cloud? It's where do I store the data at the moment of need, and how time sensitive is that data, and how quickly do I need to process and analyze that data and get it back out to the person that absolutely needs it at the moment's notice. And now it's not about bringing that with you in 5G, it's about building that into the network. And so we're taking the learnings of what you've been doing for years with on-the-move communication, with mesh networking, and with edge processing and edge compute and analytics, and building that into the next generation of networking. And that's what 5G is going to truly enable. So these are the 4 building blocks. If you're looking at 5G deployments, if you're looking at building a 5G network or leveraging a 5G network, you got to ask, what are the 4 building blocks that your network provider or your network's going to do and going to enable? So what does 5G actually do? Let's cut through all of the hype, all of the questions. We all have seen the speed tests on Twitter and your favorite news technology site. What can 5G do for you? It's not just about bandwidth. It's at the top of my 8 currencies up here, 8 attributes of 5G. But this is what's built into the 3GPP standard. This is an international standard that's enabling 5G across any carrier in the world. And so if I was standing up here with all of my carrier competitors, we're all deploying on the same exact standard. How we do it and what it enables is going to be a little different, but these are the attributes of 5G regardless of which network you use. And so you got to think about, what can I do if I can enable a network that has over 1 gig per second of bandwidth? Up to 10 gigabits per second of bandwidth. That's the sexy, to Mr. Marion's point. That's what gets everyone's attention. I think there's a lot of other interesting things within 5G that you need to think about when you're building your applications, building your solutions, or deploying it. One is reliability. In 4G and previous wireless technologies, it was broadcast technology. I have one pole, or I have one tower, and I broadcast my spectrum. Now I have beamforming technology. So if I were a tower right here, I would have 200, 300 different beamforms to each and every single one of you. And I'd be able to hold that connection directly between you and the tower with massive and multiple inputs and multiple outputs within your radios, within your cell phones. And so that allows me to give you 5 nines reliability over a wireless link. Never before capable. You add that to latency. So I talked about multi-access edge computing. If I can put edge computing, analytics, and processing at the edge of the network, and think about what applications you would put at the edge of the network, and then I can give you less than 10 milliseconds round trip between your end user device to the edge processing, to the network, and then back. That enables things like augmented reality, virtual reality without any lag. And that really is a game changer for a lot of the technologies that I was seeing out here today. Data volume, connected devices, these are about how many devices and how much data I can support in a localized environment. So I can support 1 million connected devices in a square kilometer. I can support a terabit of data per second within a square kilometer. The amount of data you can push through a 5G network is truly amazing. And that's going to enable things here in CONUS like autonomous vehicles and being able to share data and send data back and forth from the vehicle at a moment's notice. But it's also looking at 4K and 8K video, 360-degree video. Very interesting conversations on the floor here today about high-definition video and how do you do real-time analytics and processing on that video over a 5G network. The other thing on here that I think is very interesting is service deployment. Because of software-defined networking, now I don't have to configure every single edge device on the network. Every single small cell that I put out. On 4G, I have to do extensive configurations, and it takes a while for it to be provisioned within the network, and I have to tell the network exactly where it is. Because of software-defined radios and software-defined networking, I can put these small cells out and be online in under 90 minutes. All I need is fiber, power, or some sort of backhaul. That is truly game-changing in terms of deployable networks, in terms of networks on the move, to be able to move very quickly, get the communications to the point of need, and to be able to share that data at a moment's notice. There's a 9th attribute to 5G. These are probably ones that you've heard about. If you've done any kind of reading on 5G, you know the bandwidth, you know the latency, you know the promises of what the standard enables. I think the ninth one is probably the most exciting, and that's why I broke it out here for the United States Air Force, for the DoD in general. It's network slicing. So with network slicing, I can do on the wireless network what I could do on the wireline network for a long time, but I can do it at the core. I can do it within the network. And with this, I can actually create a slice across the entire Verizon network just for the United States Air Force. No one else can touch it. You have your own attributes. You have your own security. You have your own identity access management, et cetera. What's even more exciting, though, is 5G in the standard enables slicing at the connection level. So now that end user device can be sliced 8 different ways with 8 different attributes on that connection, sending the data to 8 different people or 8 different platforms at the same exact time. And so there's a couple examples here. I can send high bandwidth, high latency traffic, so think 4K video, to one slice. I can send command and control, so low latency, low bandwidth, to another slice. And so you think about this in terms of, say, a UAV operator, or a UAV, I should say. You have multiple sensors delivering data to multiple people in a multi-domain operations environment. And you need to only send the command and control data to the person commanding and controlling the UAV. You only want to send the video to the right video analytic platform. You only want to send the sensors within that UAV to a different group or to a different AI platform. And none of them touch each other. None of them cross over. So you're not giving all of the data off a UAV to the same group or to the same person or to the same endpoint. So now with that network slicing, I'm able to divvy up that data without impact and without overlap and without degradation. That's what's really exciting about 5G. And again, this is the promise of the future. This is where we're going. This is going to be the network of the future that some of the largest companies in the world are investing in today. So how do we get ahead of that curve? If we put ourselves 12 years ago when 4G was starting to be announced and standardized internationally, and you had ideas on, say, the sharing economy, and you were an investor in Uber or Lyft, Airbnb, you would have done very, very well. Our goal is to make sure that the next generation of network technologies and network investment moving to 5G doesn't just benefit consumers. We want to enable the 5G network really for enterprises, for agencies, and for the DoD. And so that's why we're starting right now to have these conversations. That's why I'm traveling the country. That's why I'm here at AFWERX, and that's why we are starting our labs to bring the Air Force in, to bring innovators like yourselves in, to figure out what is going to unlock the true value of 5G. We don't have all the answers. We are the network. We're the platform. We are going to build the very best network you can possibly have, building it for 5G with all of the true attributes, without the hype, just what you need for mission readiness and mission effectiveness. But in terms of the solutions, we need to do it together. And that's why we have these labs, because we want to bring academia together. We want to bring startups and innovators into these labs. We want to bring the users that understand the mission first. And if we start with that end in mind, then there's no telling what we can do and what we can build together. And hopefully, by the end of this process, in 5 years' time, in 10 years' time, when we have 5G across the United States, we're going to be looking back on it like we look back on 4G right now and all the innovations that have happened because of 4G. That when we look back in 10 years on 5G, we can look at all the innovations that have happened to enable the mission of the United States Air Force, to enable multi-domain operations because of the technologies that we talked about here on 5G. So I look forward to working with you. Thank you all for your time, and have a great rest of your conference.